Good afternoon, everyone. Thank you for joining us today. Welcome to our webinar, Creating Insights from Big Data, sponsored by the Villanova University Alumni Association. I'm Nancy Lane, class of 1987. It was 30 years ago today that we graduated, and we'll be having our 30th reunion. Time flies, and it's really hard to believe. I'm also president-elect of the Alumni Association Board of Directors and president of the local media association. So I work for the media industry, and so this topic today, big data, is near and dear to my heart. Really excited to hear from our speakers today. We have two alumni with us representing Bloomberg. Ansh Mehta, class of 2014, joined Bloomberg right after college as an analyst after majoring in economics and political science. Andy DeMarco, class of 93, is Global Human Resources Business Partner for Bloomberg's Global Data Group Business Unit, which is a global group of 1,500 data analysts. And in this role, Andy is responsible for the global HR agenda focused on attracting, developing, and retaining top talent while supporting strategic business initiatives associated with big data environments. So Ansh is going to lead our presentation today, and Andy will serve as moderator for the Q&A. We really would love to have a lot of questions, so throughout the webinar, we ask you to post your questions right in the question box that you'll see on the right side of your screen, and we will try to get to as many of them as possible. So Ansh and Andy, we are really looking forward to this presentation. We can't wait to learn more, and I'll turn it over to you. Thanks for being here.
Thanks, Nancy. How's everybody doing today? Well, obviously can't answer in this webinar format, but it's really great to be here today with Andy and the rest of the Alumni Association. And today we're going to be talking about creating insights from big data. As Nancy kind of alluded to, it's something that's kind of integral in many different industries and many different areas of just business and the new world we're kind of living in with all this information. And I just want to explain kind of what we're doing at Bloomberg, how we got here, and what really big data means. So just quickly, the agenda that I wanted to go over today, I just wanted to give another quick intro on what's Bloomberg and kind of how I got here from Villanova University. And then I just wanted to go right into it, just kind of give you a historical background on what data is, what makes it big, and maybe even when did it become, quote, big data. Then I wanted to kind of talk about careers in data, and then kind of go into some of the cutting edge research and applications of just information, and that by way of talking about machine learning. It's the concept I'll kind of introduce later. And then I wanted to go into kind of what Bloomberg's doing in this realm, and then kind of conclude with some more opportunities on exactly how everyone really should be involved in this kind of new industry and kind of sub-industry within doing your whole lives. So about Bloomberg LP. So it's the eponymous firm founded by Michael Bloomberg in 1981. So our boss, Michael Bloomberg, he founded the company in 1981 after leaving his job at a bank. He was actually laid off from a firm called Salomon Brothers, where he was a higher-up manager, and he was laid off, and he got quite a nice severance package, which he didn't really want to sit around with, given his entrepreneurial drive. And he wanted to start an information and data company because back in the 80s and prior to that, stocks, bonds, really everything in finance was kind of done essentially by hand. You would wake up and read the newspaper to kind of find out how different stocks and companies were trading. And that he thought was pretty antiquated because computers were becoming popular at this point, and he wanted to kind of take advantage of that and just say, why can't we just put all these things we read in the newspaper on a computer and kind of sell that as a product? And that kind of took off after, growing pains like anything else. And it created the Bloomberg LP company, which you kind of now see today across different outlets like News, which was started in 1990 under the auspices of Matt Winkler, and Verticals, which kind of started in 2009. And by verticals, I mean other kind of non-financial data sets, such as Bloomberg Law and Government, Bloomberg New Energy Finance, which kind of deals with green technologies and kind of its original research dealing with just green tech in general, and so on and so forth. It's something that continues to innovate to this day. That's kind of a brief background on what Bloomberg is as a company. And the picture you see in the middle of the screen there, that's the famous, or I guess famous if you work in finance, the Bloomberg terminal. Bloomberg Terminal is this software, and that's kind of the backbone of what Mike started in 1981 and what it is today, where everyone who works in finance and in large parts of government across the world, they kind of use this as a news and information platform to kind of stay on top of everything that's going on in the world to make a smarter decision. And this is kind of a theme that you'll hear me talk about today a good deal, just making smarter decisions using information. And it's kind of why I guess I'm here to talk to you about this at Bloomberg today. So again, quickly, just building off of what Nancy went over in the intro, my background, I majored in economics and political science in the College of Arts and Sciences. I graduated in 2014. And a few weeks after graduation, I didn't really have that last summer that some have, I started working at Bloomberg. And I started by covering a lot of these data sets that I talked about, because now we have so many different things across the Bloomberg terminal. We have currency prices, we have company information like Apple's revenue or assets or things like that across the globe. And we have different data teams that kind of cover different markets. So I started covering North American technology and media companies. So companies like Apple, Fox, Viacom, a lot of the major players you've heard of. And my role largely dealt with dealing with the financial information of these companies. So when Apple would report earnings or iPhone sales, or when Fox would buy certain other channels or news properties, it was kind of my job to make sure that this data was up to date on the Bloomberg terminal and that the quality was there. Because that's, again, quality is very important. Again, something I'll get to later on just how important it is with these new big data concepts. But currently my role has kind of shifted to more of a strategy position where I help some of these departments that you see here, Bloomberg News and Media, Advanced Analytics, Insights, a lot of these more nuanced and largely complex data concepts. So I'll help, I actually currently sit on the newsroom floor in our New York office, and I deal with reporters, editors, TV anchors, and I try to get the smartest data on the screen and into news stories so that it can better serve our customers and just the larger public that reads on Bloomberg.com, Bloomberg Markets Magazine, anywhere really. So I really just want to find the smartest ways to analyze and show all these different data sets, because let's face it, there's just so much of it out there. And nowadays, a lot of it is actually even being automated, this content, because as I'll get into later again, we have these concepts where if a company reports the same exact information, the same exact time of year, we kind of are able to front run that and able to automate that so that people can get this information to their inbox or even to their phones even faster. So to dive into kind of exactly how this goes about, wanted to kind of talk about what is data really, because we hear it all the time everywhere. I think I've already said it 20 times in this presentation, but I really wanted to talk about what is data. And it helps to start with a quote. IBM's Infosphere Lab. Now this is kind of the arm that develops things like IBM Watson. They say that there will be 2.5 quintillion bytes of data created every day. And this is actually like an unfathomable amount of data or information or any really even a number. It's hard to understand how much that is, but just picture if you had this much data on Blu-ray discs, let's say, it would be as tall as the Eiffel Tower if you stack those Blu-ray discs. And that's how much information is created around the world every day. And that's largely because data is everything. Data is text messages, photos, how many steps you're recording on your Fitbit, weather, Instagram likes. You can see even Maloney's bar tab. They keep a tab of how much people are spending, what products are popular, and they kind of make decisions off of that. Even this webinar that we kind of logged into, I'm sure you were asked to enter some information when you joined about who you are, what your background is, and that is also data. So really everything is data, in short. Again, just a little more historical background I want to run through. I think it's really important to kind of get this as a base of concept before we kind of dive into the really complex stuff. 2400 BC, this is when the abacus was developed in Babylon, and it was just, I think we've all seen them before. I'm still not sure exactly how to even use it, but an abacus is really a counting mechanism. It's the earliest kind of calculator, if you will, and it was a store of information. So anything that's a store of information or information largely is data or a database. And in 1965 is when the US government created a data center. And this was actually a big warehouse almost of data that they used to store 742 million tax records. And so this was kind of the first data center. And, you should really put that in quotes as well. In 1989, Eric Larson, he's kind of one of the forefathers of just kind of this information age. It was the first time big data was used, I guess, in publication in Harper's Magazine. And he actually was writing a piece in Harper's about junk mail and how much junk mail he got. And he was wondering how he got so much of it, and if people were storing specific information points about him and how they were kind of using that to send him all this junk mail. And I think it's something that still is an issue, depending on how you look at it today, right? Then in 1992 is really when it started to take off, data as a concept and as kind of a resource, when the internet was developed and largely popularized by Tim Berners-Lee. He was the first, I guess, database administrator in the world ever. And he was kind of the one, along with the US government and other players, to kind of develop the internet. And this is kind of how information started to get shared at a rapid pace. And then in 2014 is when we finally surpassed mobile devices over PC devices, a desktop or even work PCs. It's the first time that mobile devices surpassed that. And this is really, again, when that 2.5 quintillion number from IBM, that's when this was kind of theorized as well, because now there's just so much information, there's more that we can even get through. So how are we storing it? Storing information and data is really databasing. In the 1920s, it was magnetic tape. I'm sure you've seen these kind of cassette tapes and all these different types of tapes that have all of this reel of this magnetic strip. And basically all you need to know is chemical reactions kind of help store this information. And throughout the 20th century, this kind of got to be more and more of an efficient process through floppy disk, compact disk, SD, and Blu-ray, and today, the cloud. So before the cloud, there was one concept really that can kind of sum this all up, and it's something called Moore's Law. And Stephen Moore was kind of not Stephen Moore, the scientist Moore, he was one of the founders of Intel, actually. And he developed this kind of little device called a transistor. It's in everything that you can ever imagine. Your phones, your computers, everything you use kind of has a transistor in it or is involved in one other way. And he had this thing called Moore's Law, where basically he said science would allow this transistor chip to get smaller and smaller. And that's kind of how information took off, really. And now cloud storage is kind of how we all store information, where you can access it from any device around the world, and they're stored in these large data centers, which is this picture on the bottom. So all these different things that we've used for over a century, they can now just kind of be accessed anywhere in the world, because it's all stored in these data warehouses. A little more advanced than the thing that US government used to store tax records, but essentially it's very similar conceptually. So this is kind of a grab that I found that kind of, again, sums it up. So in 1992, we had 100 gigabytes of data per day, and now estimated in 2018, 50,000 gigabytes per second. If you think about it, your iPhones are anywhere from 16 to 64 gigabytes, and now we're thousands and thousands of gigabytes per second. So if I think I went through one thing, it's that there's a lot of information. And just as a quick aside, data in finance. Again, it's taking something that was very antiquated back in the day and kind of making it very advanced and very fast present day. So in the 1500s, everything was venture because there was no data really. People they were using an abacus to do kind of calculations still, right? So they didn't have anything but an abacus and maybe a book and a pen. So there wasn't a lot of information. So everything you kind of bet on to invest in was just a kind of shot in the dark. Someone was going to a new country to kind of invest in resources, you kind of just gave them your good faith. And even in 1817, when the New York Stock Exchange was established, there was a little more information, but think about it. It took until 1981 when Mike Bloomberg made the terminal and kind of took it out of newspaper to really digitize it and make it available for everybody. Present day, a lot of what you see in movies and kind of shows about stock trading, it kind of largely doesn't exist anymore, unfortunately. It's kind of just a caricature of people running around trading floors, trading. There still is an opening bell, but all of that stuff is largely ceremonial because everyone does everything from their computers. And again, that's largely because of the availability of information. So to kind of sum all that up, there's a glut of data information. There's so much information. I think that's the one thing I've probably drilled in, if not anything else so far. And most of it goes unused, 30 to 99% by some estimates, depending on what industry you're in. So one example of 99% of information that they gather not being used is on oil rigs. Regardless of where in the world, oil rigs have a lot of different sensors that kind of track how much oil is being pumped, how efficient these rigs are. And in most cases, a lot of the information is just to make sure that nothing's breaking. And even that, it looks like doesn't work that well if you take BP, Deepwater Horizon, and some other instances that seemingly pop up once a year. So we have all this information, we're barely using it, and that's kind of where the opportunity is, where there's a lot of startups, a lot of established companies even like Intel that I mentioned before, or IBM, that are kind of trying to take a look at it and saying, we have this information, why don't we try to analyze it and see what we can find, if there's anything important or informative we can get from it. So in terms of careers, this is kind of an open book. You might see engineering, data science, UX, user experience, or analytics and strategy positions. These are kind of explicitly data-intensive positions that you have to know statistical tools and backgrounds and kind of being able to tie it together with industry insights to basically market yourself as a value-add employee. However, this is kind of something which it's not the only way to get involved. It's really, if you learn the basic statistics, you can use any kind of market expertise to add value to your industry, because I think, as I've mentioned a few times, this is something that is important and exists across all industries because of how much information there really is. And just to kind of drive it home with a little visual, who is hiring? So Indeed, the job website, has this graph tool where you can type in any search word and it'll search its entire database for this keyword in their job postings. And you can see, I just searched data, analytics, user experience, some of the things from the previous slide. And if you sum it up, more than a fifth or even a quarter of jobs have this somewhere in their listing, have one of these, at least one of these words in their listing. And so again, it's something that's very important and has been for quite some time now. Now, to get into machine learning, I think this is where we get into a little more of the complex and exciting topics, I think. And it all starts, again, in the 1800s or 18th century, really, in Bayes' theorem. And Bayes' theorem is really, if I have information, can I make a smarter decision when I repeat an action again? So the example I like to give here is, if you have a bag that's 50% red marbles, 50% blue marbles, and the first one you pick, or the first 5 you pick are red, what are the odds that the next one you pick is red or blue? So you have more information, so you can make a smarter decision probabilistically when you pick that next marble. And this is the thing that we're kind of getting machines to do these days, and it's kind of a foundation of all of data science, really. So to track through the times, I'm not going to go through all these examples, but some of the ones you might see more familiar are when we tried to get these simple machines, which were essentially calculators, to kind of repeat these different tasks that had rules, like checkers, like chess, and like Jeopardy, and kind of teach them these rules and see if we can kind of train them using these great computing power to beat humans. And so in 2011, I think, is a much more famous pop culture example where IBM's Watson computer was taught the rules of how to understand just natural language in question form. And it played 2 of the grandmasters, quote unquote, of Jeopardy in Jennings and Berners. So it was something that was very hard to do because understanding human language is pretty complex. But in 2011 was kind of a point where in pop culture, we understood that machines are pretty powerful. And in 2016 last year, one you might not have heard of, but Google had this program called AlphaGo. And Go is a really old game with millions and millions and actually billions of different possible moves. It's a cross between checkers and chess, if I had to give a crude example. But just know that there's billions and billions of possible moves. And still, this machine was finally able to beat one of the grandmasters of Go. And so you can just see how quickly we've kind of advanced using all this information. And just want to make a quick distinction between algorithms and machine learning. So algorithm is is teaching a machine rules. And so checkers has a very defined set of rules, and you can kind of teach a machine how to play checkers. It's not very subjective. It's a very limited scope in terms of what you're doing, and you're setting parameters. And machines are better than humans at it because, let's face it, we can't calculate or run different sets of rules as fast as machines can. Machine learning is kind of a subfield of computer science where you're giving a machine a bunch of information, and you have maybe 10 or 20, maybe even more sets of algorithms, and you're able to teach it many, many different possible outcomes. So it gives probabilities to your next move in checkers or chess, and it can do much more complicated things. So I have learn in quotes on this slide because it's not really learning so much as it's taking all the available information, so every available chess game you've played, and learning how you individually would play chess so it can play you on an individual level in a much better, more strategic way. And I just listed a couple different types of approaches. You can kind of look them up on your own time. It's a lot to go into here, but again, you can see Bayesian networks. You can see how the concept, the 18th century concept, kind of still rings true today. And I would be remiss if I didn't go over the limits and consequences of all of this information and kind of teaching these machines using real data. Machines are only as good as the data we give it. So if we have biased information, then it's going to get biased results. So one kind of dark example of that was when Microsoft kind of created, I believe late last year, a Twitter bot. I forgot the name of it, but it created a Twitter bot to kind of learn human conversation, and it kind of just let it loose on Twitter to learn from all these different tweets how humans kind of talk to each other on the internet, which, as you can tell, would have been a pretty bad idea. And it was, because within minutes, I think it was 20 minutes that it became a very biased and very crude machine, really. And they had to take it offline and apologize immediately. So that was a quick example of how this machine kind of can be biased by our own biases. Autonomy, traceability, letting machines make these decisions based on their different biases, you could just see how that's flawed. And traceability, if we really wanted to understand how some of these machines work, a lot of people don't get that once you get very complex with some of these machines, it's hard to understand how they work, and we can't really go back and see how they made the decision when they get very complex. So it's things that people are grappling with on an ethics and on a really just user scalability level. And I included some of the names here that are very skeptical, like Elon Musk, Stephen Hawking, Bill Gates has expressed his skepticism about these types of concepts. And you can see Elon Musk had this tweet a couple years ago. I think there's maybe even some more recent ones, but I think I picked this one because he said it's potentially more dangerous than nukes. And some of this article by Bostrom here, it really just talks about some of the things I mentioned before, that if we let some of these machines loose on healthcare systems, on these different industries, that it could be very dangerous if there's no human intervention. So it's not something where we can just kind of eliminate human decision-making altogether. Just something to be cognizant of. Now I wanted to get into some of the exciting use cases. We kind of gave a lot of information, a lot of background, but I think it's really clear to give 3 really clear industries where this is already being used, and where you're already using it, whether you know it or not. And so Amazon, the retail behemoths, they use a lot of different machine learning, and they have entire data science teams that are committed to improving their platform in many ways using machine learning. So they have a large quantity of customer data. They know what we buy, when we buy it, how much we're willing to pay for it. So that's very powerful. And they use different patterns to kind of predict how and when we're going to buy certain things, how and when they should run. This is a picture right here of their logistics warehouse. So these robots are autonomous, and they kind of are able to learn when and how to get some of this stuff in their warehouses to make delivery even more efficient. And one thing you might have heard on the news is that Amazon is facing a backlash for a lot of different fake product reviews. And so they're actually using, again, a lot of this current product review data that they have to be able to weed out these different fake reviews. And so it's very complicated and complex, but their end goal is really just to get, again, a better user experience. And the thing I think we know the most of is, or that we have the most experience with, is the product recommendations. They start with this model, like I've been saying, they evaluate, optimize, just test, retest, make sure they don't get any false results. And what you kind of get is this. I'm sure we're familiar with this interface. I think all I searched was peanut butter. So I just searched peanut butter on Amazon. And this little tab here below the product, the customers who also bought this item also bought. And it shows a bunch of different comparable products. And if you scroll through, which I don't have here in this graph, but it shows you comparable products, comparable peanut butters, complementary products like jelly, and it goes on and on with different crackers, different fresh products, bread products that they can deliver to your door day of. So it just goes to show you how they're taking all this information they have and kind of innovating to create a much better experience for us, and it ends up being cheaper too. One of the most exciting things I think of when I think of applying big data is healthcare. It's something which is, we always talk about the costs associated with healthcare, the trouble with diagnosing or misdiagnosing. Now, right here in New York, the Mount Sinai Hospital had a project called Deep Patient. Sounds like Deep Mind, like what Google and IBM are kind of working on, and it's very similar, where they gave 700,000 patient records and patient health charts tracking over time, and they were able to kind of teach it how to diagnose diseases. And so you can see on the right here on this table, these are percents on exactly how accurate the machine ended up being for diagnosing some of these diseases. And in a lot of these cases, they were at par or better than doctors. And I put limited traceability here, going back to the limitation slide, because a very interesting anecdote to focus on schizophrenia here. Schizophrenia is actually a pretty difficult disease or condition to diagnose before some of the real serious symptoms occur. And one thing they started to notice with Deep Patient was that it was able to diagnose schizophrenia, not just with 88% accuracy, but much quicker than doctors were able to do it. And when they had to go back and figure out how the machine learned to do this, it's not actually something that's easy to do. They weren't able to just go back and say, I went from X to Y to Z to diagnosis. That's not really how a lot of these systems work, again, because they're so complex. Again, a really simple example to kind of bring it home is, I know how to multiply numbers, and I know that everyone on this call definitely knows how to multiply numbers. However, I can't really understand how in your life you understood and learned multiplication. I know that you know it, and I know the outcome of you knowing it, but it's hard to pin down exactly how you came about through all the different classes you've had and experiences you've had with math to get to that solution. So it's kind of something, again, really hard to know how exactly these machines are getting to these solutions, even if they are correct ones. And now the last example, again, very much in the news always, is autonomous vehicles. And you can just see with this graph here from CB Insights just how many autonomous vehicles, how many companies are working on this type of project. And this kind of spans the globe. So you have a lot of US companies like Microsoft, like Apple, and you have a lot of foreign firms as well, like the major car companies. Like in Germany, you have Volkswagen, BMW, or even in Asia, you have several other companies that, like Baidu, that are really trying to get on the forefront of this autonomous vehicle. And again, similar to the other industries where you're just taking large data sets of traffic patterns and other things to kind of create an autonomous vehicle. But the tough part is there's a lot of human error and a lot of uncertainty on the roads, which I'm sure we all know. And that makes it a very hard project, and it's why no one has really cracked it yet. And PwC does a really great report every quarter, I believe, or every year on exactly how far we've come in autonomous vehicles. And the case that they're trying to make is that it's not really clear cut on exactly how many cars, if we really break through this technology, are really going to be autonomous. So it's something that it's so hard, and I wanted to demonstrate that using this graph, that the lower line is the base case, and the red line or maroon line, however you see it, is the most positive scenario. And even then, only a third of companies or cars on the road will really be autonomous. So it's something that it's so hard that no one is really that sure that it'll even be something that will be ready in the next decade. And the common thread for all of this is, like I've been saying, it's data. It's all this information that everyone's collecting and really barely using, and combining that with domain expertise, whatever that domain expertise might be. That's really how we kind of make this data actionable and create insights from it. And because information is exploding so fast, I think that's why this is how it explains this lack of data-focused jobs that exist today. Now, just to go over kind of what I'm doing at Bloomberg in this realm of big data. Again, we're trying to bring all these concepts that I talked about to the financial data sphere. And really, we're trying to do this in many different ways. We already leveraged some of this technology for some of our existing products like extraction, customer service, analytics, to kind of understand what kind of questions our customers ask and what kind of information they really want to see. But the challenge is not as tough as the challenge in the auto world, but some of our challenges are kind of living in this non-standardized world where financial information is presented in so many different ways in so many different languages. There isn't kind of just one way that companies fill out information. So on the left, you'll see this chart, or this table rather. It's the financial information for Ford Motors. It kind of just shows some of the revenue. And on the right is a similar table for the exact same time frame, the first 3 months of this year for Toyota. And they look kind of the same, but there's so much nuance that there's just so much information that we have to parse through and kind of understand exactly how to create just one type to even look at. So there's a lot of different work that goes into just, we call scrubbing the data and making it usable. After we get over that challenge, we want to create insights. So we have all this information. We know how companies report. We even know kind of what information our clients deem as important. So that's kind of our lowest hanging fruit, so to speak. We try to automate market alerts about salient data points, and we call this key insights. We try to take revenue numbers or maybe different economic indicators to kind of send these automated alerts. And that's something which I've been working on for the past year and a half. And it's, again, something like what IBM's Watson does, where we have to take the language written in reports and kind of extract the most important information and deliver it on command to clients. So that's kind of stuff that's already in the works. Now, what we're kind of doing that's on the cutting edge is what drives a company or industry or even a country. And so we have all these different things we take a look at in the sub bullets below, but it's really, if we could take numbers like income numbers or certain other indicators that are released in the United States and elsewhere, can we try to see how related they are to a company's earnings? So for example, if today we learned how much US wages increased in the past month, can we kind of predict how much or in what direction the revenue for, let's say, Target or TJ Maxx or places where people spend this income, how much it will proportionally increase in the coming months? So that's kind of this predictive stuff that we're trying to do at Bloomberg. To go over some of the key insights that I mentioned before, this is a screen grab of things that are already sent to clients today, where we'll take, so this is Allergan, a large pharmaceutical company, and we take different drug trials and all this different information that's released every day about this company, and we create these automated alerts that are sent directly to clients. And so all the language you see here is automated and sent directly to clients upon release. So we can kind of focus on the more cognitive stuff. And going back to how we find these drivers of what makes a company tick, we take a metric, let's say, like we're saying, company's revenue, and we really try to put all this data, like I've been saying, in our machine learning model to create what we think is the most important insight. What is the link between the driver and the metric? And this is just a kind of a gimmick. It's kind of an output of what we would see. So all along the outsides here, all the different economic and financial indicators, and the pockets of red and blue are how strong the relationships are. And it's the same indicators on both sides, which explains the most blue going down the middle. But you can kind of see how we tackle what metrics and what things to look at in this whole sea of information. And this is kind of the output. And this is the kind of example I wanted to drive to you, where we take a company called Kansas City Southern. They're a rail company that operates in the southeastern United States, or the southern United States, really. You could see a map of all of their rail tracks. And one thing which our model kind of spit out that wasn't really talked about in any of the company's financial reports or on the news at all was the Port of Houston. You can see it's kind of close and runs through Houston in one way or another, but none of their revenue we saw ran through Houston, or nothing mentioned Houston in their reports. And you can see on the right here what the company does for revenue, what they transport in their rail cars: agricultural, chemicals, petroleum. And when you take a look at what the Port of Houston operates in, it's actually some of the very similar products in the same capacities. So we kind of found a totally new insight that wasn't talked about on the news at all, and we were able to create something new that the clients were able to look at. So this is kind of just one quick example And we have hundreds that we're taking a look at every day to kind of understand what is new and fresh that we can show to basically anyone who's willing to listen on why these are related. So in conclusion, data analytics and machine learning, it's a very nascent field. It's very up and coming. It's very new. And that's largely because we haven't had this much information up until the past couple of years when it started to explode with mobile and other applications of this information technology. And that's basically led to so many different applications of all of this. And just to drive it home one last time, just follow the money. So this is venture capital spending in just AI and machine learning. And so we have well over $600 or $700 million every quarter, and just in the United States, going into just investing in these startups in kind of finding new applications for it. And with all of this money, obviously follows all these different jobs that are in these different fields. And to touch on specifically some of the opportunities at Bloomberg, we have a lot of different data-focused postings. This is actually one very specific and very real job posting for a junior data engineer. And you can take a look after we send this slide deck out on exactly what all of this says. But essentially, it's some of the concepts I've been touching on this entire presentation. And it's really creating a visualization of some of these large data sets that we work on in global data and beyond, and kind of being able to derive business and really intelligent insights from all this information and packaging it up for a myriad of different applications. And to conclude, very emerging technology with really unlimited applications. And I say unlimited, and I kind of mean it, because it's something that if you look Elon Musk and some of the other leaders in this field, they say that it's unlimited, that it's up and coming. And again, with that, the ethics code is still unwritten. There's a lot we don't know on how it's used, how it's applied, and how really we should be using it. I think it's safe to say that it's in the news all the time, how much information and really hacking and things like that can get out of hand, and how to be kind of careful with all of this information. And I think this kind of sums up what I had to say. I'd love to take some different questions from anyone who's on. I think the floor is now up to you all.
Sure. Hi, everyone. It's Andrew DeMarco. I saw a couple of questions went into the question box, and we'll have about 9-10 minutes to look at questions as well. So thanks so much, Ansh. I think that was a really nice summary of history through current and even future and some of the questions. Looks like we're getting questions on a couple of different topics. I'll start with one that relates to financial industry. We have a question that asks, what role and influence is big data playing in the realm of money management, the money management industry? Are we seeing that machine learning, big data are making more effective decisions than humans, for example?
Yeah, that's a very good question. And actually, it's one of the, I would say, the most salient themes that is out there right now in finance. And it's kind of, it really boils down to the active versus passive debate. And that's really what it's called if you Google it. But to sum it up, active money management, it's giving money to an investment advisor or, a traditional vehicle like Vanguard or State Street, and these money managers who've done this for hundreds of years. And they basically take what you would like to set away for retirement or just as investment, and they use their financial knowledge to kind of get you some returns. Now, what's happening now is you're seeing machines are learning from kind of how the market operates. So if we feed it large data sets on how stocks or industries or even countries perform, it can kind of, the machine, can actually understand how to make these decisions. And the biggest and most important thing of why people are choosing machines, and to be clear, the tide is shifting away from active management, as in managed by people, to passive, these machine managed companies, because it really comes down to cost, because it costs a lot more to pay traditional money managers to manage your funds versus just paying a marginal rate to these different automated investment advisors. And I think there's a few more players, but there's really two in the US that are kind of taking advantage of this, and two companies called Betterment or Wealthfront. I'm sure if you listen to any of the top 20 or 30 podcasts that are out there, not even just finance, really any podcast, they advertise on these platforms. So Betterment, Wealthfront, these are two companies that they use machines to kind of manage your money, and if something's doing poorly, they will sell it and they'll buy what's hot, what's popular. And by kind of automating this process, there's lower fees and you kind of guarantee at least some sort of stable return. And I've actually had the pleasure of meeting some of the executives from both of those companies, and it's really interesting to see how they're thinking, because while it is cost driven, they're really trying to use the best information and data possible to kind of get the most seamless and easy experience for all of these customers. And full disclosure, I am a customer of Betterment. I mean, I think they are the way to go, any one of them really, because they offer great products, and it's really just, it's amazing to see what they do. It's just really very innovative.
That's great, Ansh. Let me go to a slightly different topic. Just you talked about use cases from other industries, et cetera. The question is, what, in your opinion, what percentage of companies are really utilizing big data for central decision making? And so that could be strategic planning, marketing, et cetera. Any sense of the percentage of companies that are really in this space?
That's a very good question. It's hard to pin down on exactly how. It's really hard to quantify something like this because, again, it is so nascent. It's something that a lot of people have been using in some ways, like some of the technology companies like IBM, Cisco, some of the traditional large tech companies. They've been using information to make decisions for some time. But to really pin down on exactly how many are using these big data applications, again, it's very tough to say. But the short answer is really everybody is using it now in some capacity. If you're a leading company in your industry, you're using it in some way. And I think a proxy for kind of explaining how much it is being used really is look at the position of a CTO, a chief technology officer, or even something you're starting to see out in Silicon Valley, a CDO, a chief data officer, which I think there is debate on whether really you should have one or not, but really it's something that you see popping up over and over again, where now most people have a CTO that not just manages their technologies and how they report and what kind of they do to technologically drive their business, but really to understand all the information that's coming in and how to drive strategy vis-a-vis that information flow.
Thanks. Switching topics, we got questions from a lot of different topics. So we got one from kind of an HR perspective or almost a societal perspective. The question is, what's the potential impact from an HR perspective? Are there positive or negative societal impacts on job growth and loss?
Yeah, I mean, I think it's a two-part question, I guess. So the first part being, how can we, use all this information to make more informed HR and other decisions? And I think that's something you're definitely, I mean, Andy, you could probably speak to this, how we use information about not just candidates, but about the graduate landscape that kind of target or even pinpoint different possible candidates and kind of understanding really what that looks like. But then I think the second part, which this is the question which it's starting to be asked, and if you really follow the political tides, it's something which has really become, in du jour as of late, and how machines, data, all this information, how they're leading to job growth, but really job loss is really the one question which I don't think has been tackled enough by really anybody, let alone like lawmakers, because it's something that is only going to get more. We talk about it in hyperbole now, but it's really something that's going to even become more of an issue going forward, where if I do have self-driving cars, let's say, how does that affect the cab industry, the ride industry in general? One actually example, which you're going to be seeing in the coming year or two really, is applying automated driving to tractor trailers. So there's a company called, I forgot the name, but it's now owned by Uber outright, and they've been testing self-driving trucks for some time now. And last year in Colorado, on one of their test tracks, it was actually, I think, a case or a couple cases of Budweiser from a factory in one side of Colorado all the way to Denver. I think it was Aurora or somewhere else to Denver. And it was a couple hundred miles, and it was a completely automated trip. There was a human involved as a driver, but it was a completely automated trip. And it's definitely going to lead to, I think there's 3 million truck drivers in the United States currently, and it's going to lead to dislocation in this industry. And I think that's just one example of how it's going to happen elsewhere. And the short answer, not really sure how to tackle that. It's very tough to kind of replace all these different people at such a fast rate. And it's something that lawmakers will have to grapple with either a machine tax or something like that going forward. It's tough to say, but it's something we just need to be cognizant of, that it's happening, and then we can kind of make smarter decisions as a result.
Yeah, great response. There's a lot there from the HR and societal aspect. I mean, I'll just add from HR perspective, lower skilled data jobs are increasingly being automated, whether that's literally machine learning, natural language processing. And so we're seeing more and more higher skilled data jobs that are either checking the work of computers or using statistical and applied tools to go farther. I think we'll have time for we have time for one more question, one last question. We'll end at kind of that micro level. Ansh, what tools are you using in your current role, and just generally, what kind of tools do you use as a sort of a practitioner of big data?
Sure. Again, you saw my background in political science and economics. I didn't have much of a technical background aside from just stat tools from college, so a lot of it had to be learned on the job. And again, not just at Bloomberg, but I think a lot of different companies are willing to kind of bear those costs of their workforce learning these technical skills. And since I started, I think one of the most important things that I've picked up is at least a basic understanding of what programming stack, and by stack I mean just the different languages and tools, whatever your firm uses, not being able to actually code and do the programming, but understanding how to read and at least understand some of this stuff, because it seems daunting, but it's not that hard once you pick it up, and once you kind of see how tangible applications like those key insights and things that I was showing, how to kind of work through those on the programming and engineering side. So being able to understand those, and for me specifically, I've learned that with mainly Python and SQL. SQL is a structured query language. That's universal really across any business that uses technology in any way. Using SQL is really important, and it's universal in that sense. And aside from that, I've used other statistical tools like R programming and the like to kind of just being able to do all that analysis on my end. But I think that kind of covers it. And then there's just other kind of business intelligence platforms like Jira, for example, a product of the company Atlassian, which kind of allows you to track projects. And it's something that engineering teams use regardless of what company they use. Just understanding project management workflow tools, very important, and it's only going to become more so going forward.
Great. Well, I think we are in wrap-up mode here. I want to thank Ansh and Andy for such a great presentation. And Ansh, it's probably the best explanation that I've heard of machine learning. So thank you for making it so simple to understand. We have a group going to Google next week, and we're meeting with the machine learning team. And I just feel better prepared after hearing your explanation and examples. And I'm certain that everyone on the webinar picked up a thing or two or three. So thanks so much. Just want you to know the webinar has been recorded. A link will be posted to the Alumni Association website. That's alumni.villanova.edu. And just big thanks for joining us today. Thanks to our presenters, and stay tuned for future Villanova webinars. Have a great day, everyone.